Okay, today we're going to learn about comets, meteors, and asteroids. We're not going to worry about Pluto quite yet, but we are going to talk about comets, meteors, and asteroids and the differences between them. So let's go right ahead and get started. As usual, make sure, actually, you're going to be illustrating for this one. So anything here, you'll be adding to an illustration. So red stars mean you're adding to an illustration. Okay, so let's continue. Some important vocabulary that's really essential. A comet is an icy object. Comet is ice. It has a tail when it gets within something called the frost line due to the ice's sublimating. And I'll talk about what that means. And a dust tail points opposite its direction of movement. Okay, and the important thing to note is our gas tail points away from the sun. So our sun must be here because the solar wind is pushing the gas from this comet away. It is melting. It is not really melting, but it is sublimating. It's even more crazy than melting. Instead of turning a solid into a liquid, which is melting, we are turning a solid into a gas, which is called sublimating. All right, so the sun is sublimating this comet and pushing its gases away. However, the comet is going this way because its dust tail is opposite its direction of motion. So the comet is going this way down here, and the sun is over here. Now, what's this frost line? Well, a frost line is just an imaginary line. It's where if you go past it, it's cold enough for gases to freeze. So we have our comet. It looks like it's going this direction right here. A comet that's outside of this frost line right in here will not be sublimating. So we'll only have one tail, a dust tail. But when it crosses into here, we're going to have two tails. We'll have a dust tail and a gas tail because the solar wind will be sublimating. It'll be hot enough to turn this solid ice into gas once it's passed here. And solar wind is the continuous flow of charged particles from the sun that permeates the solar system. It's a force that pushes outward from the surface of the sun. Now, where's the frost line, right? It's between here. It's easy to note. You can break up the solar system into two places, really. Terrestrial planets and then our big gas giants right in here, okay? So the small ones and the big ones, and in between, we have our frost line right in here, okay? So if a comet is between the sun and the frost line, it begins to have two tails. And I say the word melt to help you out, but it's not really melting. It's what we call sublimating. All right, so this comet must be in between the gas line or the frost line. It must be somewhere near Mercury, Venus, Earth, or Mars, but it can't be past the asteroid belt, or it can't be near Jupiter, Saturn, Uranus, or Neptune. Can't be, right? If it moves past the frost line towards the gas giants, Jupiter, Saturn, Uranus, or Neptune, it freezes again, and now we'll just have one tail, its dust tail. Now, comets are made of mostly gas, and this gas is frozen, right? If it gets too far away from the sun, the gas will freeze. That's why if the comets get close to the sun, they begin to fall apart. All right, now there's two types of comets. There's short period comets and long period comets, and it's pretty easy to describe the difference. This is in the inside of our solar system, a short period comet. It might go a little past Pluto into something that we're going to describe as the Kuiper Belt in a future slide, and then long period comets, really long orbits that go way beyond our solar system to the edge of our solar system. So short period comets means a short trip. Long period comets means a real long trip. Okay, and this is what the trip we're talking about. Here we have our planets. Here's Pluto's orbit. And then we have all these little pieces of gas and dust and ice that are in this little plate. It looks like a little plate right here. And the sun is in the middle. And this is called the Kuiper Belt, right? Now, this is where a short period comet might orbit. And we have what's called our Oort cloud. So we have our flat plane, which is our Kuiper belt. And then the rest of the solar system is this crazy thing called the Oort cloud. It's not in a disk. It's not on a plane. It's not flat. It's a whole sphere. So our solar system is inside this big sphere of little tiny pieces of ice and dust and dwarf planets and other things. And long period comets will go all the way out here and back, or way, way out and back, okay? So long period comets into something called the Oort cloud. Short period comets, really just anywhere between the sun and what we call the Kuiper belt, the edge of our flat disk. All of this stuff is orbiting the sun right here, just like our planets are, okay? Now, a few other things. Asteroids are not like comets because comets are made of ice. Asteroids are big, rocky, solid objects, and there's a lot of them in something called the asteroid belt. Okay, it's between Mars and Jupiter. It's a good thing to see and recognize this because it helps break up the big planets and the small planets. Asteroid belt splits up the gas planets and the rocky terrestrial planets. Okay, so there's a lot of asteroids right in here, and these could have accreted to form their own planet. In fact, there's one that almost did called Ceres. So we almost have a planet between Mars and Jupiter. But Jupiter's gravity is messing with the asteroid belt so much that Ceres cannot accrete and it cannot grow, which is kind of neat. Now, the other things you should know, meteors, okay? These are all the same thing, meteors, meteoroids, and meteorites. We just call them different things depending on where they are. Okay? A meteoroid is like an asteroid. It's something smaller than an asteroid that's floating around in space. However, sometimes these meteoroids can get into our atmosphere and they streak across the sky and they can be called meteors, right? Only when something is in our atmosphere is it called a meteor. And that's why you have a meteor shower. You never have a meteoroid shower, a meteor shower, because these meteoroids go into our atmosphere and they burn up and then you see them. They're called shooting stars. Now, most of them burn up and they're really small. They can be pieces of dust size, baseball size, and they burn up. Bigger ones can land on Earth, and when they land on Earth, we call these meteorites. Okay, they were burning up, but they didn't burn up all the way, and they're called meteorites. So meteorites are not dangerous, only if you stub your toe, right? Meteoroids are not dangerous because they're not crashing through the sky. Meteors can be dangerous, but it's very, very unlikely they can be harmful. And so here's our summary right here. I hope this was a valuable presentation, and reach out with questions.